Dear friends, Maths Aspirants organizes online problem-solving sessions to help the students who prepare for different national level competitive examinations. As a part of that, today we have Miss Unnati Shukla is with us. Miss Unnati already done one session in our platform about basics of ordinary differential equations. Today, she will discuss some topics related with that in continuation of her first lecture. Ms. Unnati did her MSc from Maharshi Dayanand University, Rohtak, Haryana, and she qualified JAM with All India rank 31, CSIR-NET with All India rank 39, and GATE examination with All India rank 77. And Ms. Unnati currently pursuing M.Tech in data analytics at IIT Dhanbad. Apart from this academic brilliance, Ms. Unnati is actually having lots of other talents and having all the potential to inspire the students. So, yeah, in the interactive session, you can discuss your problems and your queries regarding preparations, and how to avoid frustrations during studies can all be discussed with her. And I take this opportunity to appreciate Unnati for joining with us and showing the readiness to engage sessions to help the juniors. And I use this opportunity to express my sincere gratitude and thanks to her for being with the activities of Maths Aspirants groups. I welcome everyone to this session, and I'm sure that today's session will be really helpful in your preparations. And I once again welcome everyone. Welcome, Unnati.
Thank you so much, sir. It's a great pleasure for me to be a part of Maths Aspirants and having to interact with lots of students. So this is a lecture in continuation with the previous lecture that I took maybe 2 months back. And in that lecture, I told you many interesting facts about ordinary differential equations, which you might ignore while preparing. So we covered autonomous differential equations in the last lecture. And in this lecture, I'm going to continue with exact differential equations, linear differential equations, integrating factors, and singular solutions for a differential equations. And we're going to do lots of problems. This session is going to focus on your problem solving skills more than the theory part. So our main focus is going to be on problem solving. So let me begin, and let me just start with the types of solutions of a differential equation. I hope my screen is visible to you. You can see types of solutions of a differential equation. And there are mainly 3 types of solutions for a differential equation. But generally, we used to study, in our college, general solution and particular solution. But a more important kind of solution is also the singular solution, which we are going to do in this session. So what is a general solution? So suppose you have a differential equations, and the differential equation, let's say dy by dx is equals to 2x. Let's say this is a differential equation. Now, when you solve this differential equation, you get a family of curves. Let's say you will get, in this case, y is equals to x squared plus c, something like that. So when you make a family, when you solve this differential equation, you get a family of curves. You don't get a single curve while solving an equation. You get a family of curves. So this arbitrary constant denotes that you are having a family of curves. So what are these family of curves in this case? X squared plus c. The solution is x squared plus c. So you are going to get these kinds of solutions in this case. So remember, whenever you're solving a differential equation, you get a family of curves, not a single curve. Because when you're integrating, you're getting an arbitrary constant. And with the help of that constant, you're getting infinite curves. So general solution is basically the family of all those curves which you get by solving the differential equations. But this is not always the case that you always get a general solution for a differential equation. We'll cover that later. So this is general solution. Now, the second type of solution is particular solution. When you put some specific value in the general solution, you get particular solution. For example, y is equals to 2x plus c. If I want to put like c equals to 0, I'll get a single curve, y is equals to 2x. Now, y is equals to 2x is known as a particular solution for the differential equation. I hope you might all have an idea of general solution and particular solution. But when we'll go to singular solution, you'll notice something which you haven't already. So particular solution is when you put some specific values of the arbitrary constant, you get a particular solution. So I'll share these notes with you. And here you can see y is equals to 2x plus 1, y is equals to 2x plus 3. If y is equals to 2x plus c was a general solution of some differential equation, then we know that y is equals to 2x plus 1, 2x plus 3, 2x plus 2.5, whatever, is going to be the particular solution for that differential equation. Now, particular solution can also be of this type. I've written that, type 2. Just a second. Okay. So all those differential equations which do not have any general solution. For those differential equations, for example, this differential equation I've written here, the derivative mod of y dash plus mod of y is equals to 0. Such kind of differential equations do not have any general solution. Because when you solve this differential equations, all you get is y is equals to 0. You can see that these two are modulus values, and you are adding two modulus values to get 0. So you can clearly get that y dash is equals to 0 and y is equals to 0. So y is equals to 0 becomes your solution, right? So in this case, for these kind of differential equations, y is equals to 0 is the only solution. So in this case, this is called a particular solutions. Remember, general solutions are always a family of solutions. But here, you get a single solution. So these solutions are particular solution. All right. For example, if I give you this kind of differential equation like this, mod of y dash plus mod of y is equals to 2, you can clearly see that this differential equation has a solution y is equals to 2, and this will be the only solution. It has a proof. Basically this thing has a proof, but you don't need to go into this. You can see these kind of equations you might see in exams, and you can directly, see that y is equals to 2. If you put y is equals to 2 here, and y dash becomes 0, it satisfies the differential equation, and you get this solution. So our focus is mainly on solving problems in this session. So I'm not going to go into the details of the proof. So we have understood what is a general solution, what is a particular solution, and another type of particular solution. Now let me get into the singular solution, which is a third type of solution of a differential equation. I hope I'm clear until now. If you're having any little doubt, you can ask me right now or in the later part of the section where we discuss with you your questions, okay? So what is a singular solution? Well, I have written that a solution which is the envelope of the general solution. So here the term general solution and envelope are very important. What is the meaning of envelope? So for example, I have a family of solutions. Let's say y is equals to x square, y is equals to x, x is equals to c, y is equals to 0, right? Yeah. Suppose I have a family of solutions. Suppose this is my general solution for some differential equation. So I get a family of solutions which look something like this. You won't even get spaces between them. You will have this curve at every single point of this horizontal line, y is equals to 0. So what you observe from here that every curve has a common tangent in this case. What is that common tangent? Can you observe? Y is equals to x square. What is the tangent for y is equals to x square? Let's look at this. Y is equals to x square. What is the tangent for this? Y is equals to 0. And even if you want to draw like y is equals to x minus x1 square, which is this graph here, this also has a tangent y is equals to 0. So all these curves in this y is equals to x minus c whole squared, all of these curves have this common tangent, which is y is equals to 0. Now, y is equals to 0 will be called the envelope of the general solution. So the all solutions collected, when they have a common tangent, this common tangent is called the envelope of the general solution. General solution means all those curves which I mentioned right here. So let me just give you this example by solving a differential equation. Let's say we have a differential equation and dy by dx is equals to root y. dy by dx is equals to root y. Suppose this is our differential equation. Now you can solve this differential equation using variable separable method, the easiest method. So when you do that, you separate the variables, you get dy by root y is equals to dx, and the integrating both sides. And when you solve this, you get 2 root y is equals to x plus c. And when you solve this for y, you get y is equals to 1 by 4 x plus c whole squared. Now this is the general solution for the differential equations. But there is one hidden solution that we haven't considered. Look at here. Look at the differential equation. If I put y is equals to 0 in this differential equation, does it satisfy the differential equation? Anybody? Y is equals to 0 satisfies the differential equation? Anybody wants to answer? Yes, you can try by substituting y is equals to 0 in this differential equation. And I'm asking you, does y is equals to 0 satisfy the differential equation or not?
Yes.
It does satisfy, right? But when you solve it for like general solution, you don't get y is equals to 0 as a solution. You can't get it. You know, this is a family of parabolas. But y is equals to 0 is not a parabola. That is a different solution. So there is something you might have missed, you notice. Because y is equals to 0 satisfies the differential equation. But when you're solving this differential equation, you're not getting that solution. So in these case of uncertainties, what we will get is y is equal to 0 as a singular solution. Right. So you get all the family of curves, but y is equals to 0 is one solution that you missed. But when you draw these, and I know that it's not always possible to like graph your solutions, but in this easy case, let me just graph it for you. It is same as like I draw y is equals to x plus c whole squared. This is 1 by 4 x plus c whole squared. It's a family of parabolas. And when you draw them, you see that this is a common tangent, y is equals to 0. Right. So y is equals to 0 in this case is also a solution of differential equation. So your question might be, how will you identify that you're missing on to some point? I will tell you that. Okay, you don't need to worry about that. How in any question you identify that you get a general solution, right? So let me take an example which was asked in maybe JAM 2021 or JAM 2022. And one more thing I wanted to share here. I'll share with you with that question. Let me just discuss it with you. It was maybe asked in 2021, but before that, let me discuss with you some basic question. Suppose I have a equation y dash is equals to y raised to power 2 by 3. And I have a condition y0 is equals to 0, right? Let me discuss with you some basic question, then we'll move on to the first question and you will answer of this question, okay? So this is our initial value problem kind of thing, right? There's one thing which you should know, which is called existence and uniqueness theorem. Please make notes for this theorem. This is the most important theorem of ordinary differential equation. Uniqueness theorem. What does it say? It says that if you have like a differential equation of first order and some conditions are given to you, y a is equals to b at some initial point. This differential equation is defined at some rectangle where x belongs to ab. Y could be, in this case, I've taken as real number. So if the condition is, if all these conditions are given to you and someone says that this function of xy is continuous in this domain, in the given domain D, fx is continuous in D, then we know for sure that this differential equation, this system, this initial value problem, what we call this is initial value problem. When you are given a differential equations and the value of the solution at some particular point, which is the initial point, then that particular problem is called the initial value problem. Now, if fxy is continuous in D, then this guarantees that the solution for this initial value problem exists. What we call this in short form is IVP. The solution for this IVP exists for sure. We don't know whether it's going to be infinite or it's going to be unique, but we know for sure that it exists. And this is a condition of sufficiency. This is not a necessary and sufficient condition. This is just a sufficient condition. If your function is continuous, then the solution for this initial value problem exists. Now, the second point is, if you know that the partial derivative of f with respect to y, because f is a function of x and y. So if you're checking that the partial derivative of f with respect to y, if this exists around the point, y is equals to b was given to you. So if this exists around the point AB, then the solution must be unique. So let me give you an example so that you're able to understand it easily. For example, I have an equation y dash is equals to, y dash means dy by dx. I have an equation y dash is equals to y square and y0 is equals to 0. We want to solve this. So first we'll solve this by our basic method that we know is variable separable form. Dy by y square is equals to dx. You will integrate it for on both sides. Yeah. What you will get? Let's solve it. Minus 1 by y is equals to x plus c. Now this condition doesn't make any sense for this kind of question because you can't put y is equals to 0. You can put x is equals to 0, but 1 by y is not defined around. Even if you're trying to do this, y into x plus c, you will end up getting, if you put x is equals to 0 and y is equals to 0, what you'll be end up getting this minus 1 is equals to 0, which is, not true. This condition has no meaning in this case. Let me just change it a little bit. Let me do it as y0 is equals to 1. Okay. Now, if you solve this differential equation, what will happen? Y is 1 when x is 0. We want to find c with the help of this initial condition. So what is c? Minus 1 over 1 is equals to 0 plus c. So you will get c is equals to minus 1. Now the solution of this differential equation becomes y is equals to minus 1 over x plus c, which is x plus c. Plus c means minus 1. So this is the solution for your differential equation. Now you will say that this solution is not defined everywhere. Yes, it's not. So the thing that existence and uniqueness theorem guarantees us is that the solution will exist, but it will exist around the point AB, in the neighborhood of AB, not in the whole domain. The solution will exist. Oh, sorry. YA should be equal to some whatever x naught. This B is different from that B. Okay. So the solution will exist around A, x naught. You have a guarantee that the solution exists around this point, nothing more than that. So this is a drawback of this method, but it's still a very important theorem. So let me apply. I solve this equation with the help of what we know, variable separable method. Now let me apply the theorem to know if the solution exists or not for this, using the existence and uniqueness theorem. So first statement says that the function has to be continuous in the domain, whatever domain you were taking, or around that point. You can also say that function is continuous around that point, whatever point you were taking. Here it is a comma x naught. So around that point a comma x naught, the point has to be f of xy is equals to y square has to be continuous. Is it continuous around that point? Yes, it's a good function. It's a nice function. It looks like a polynomial and it's always continuous. So first condition is satisfied. So this means I have a guarantee of existence of solution. Now what about the uniqueness of solution? Now if you partially differentiate your function with respect to y, you get 2y. And around the point 0, 1, this partial derivative, I mean this function, is continuous, right? Around this point, this partial derivative has no problem. It's continuous. So this guarantees me that this equation has a unique solution. Now you might ask, what is the benefit of doing all this work when we can find a solution for a differential equation? Well, you cannot always solve a differential equation, and that you know. And in the question, when examiner is giving you a question, those IIT professors, they don't expect you to solve the whole question. They expect you to apply the theorems that you know. So they don't ask you the actual solution. They ask you, like in this question, question number 1, I think it was 2021 question. They asked you, this equation, this system, this initial value problem has exactly 1, exactly 2, finite or infinite solution. They did not ask you the actual solution. Rather, they're asking you the number of solutions. So in that case, you need to apply the theorems. You don't need to solve the whole question. And it's not always possible to do so, right? So in continuation with this, we have a beautiful result that can help you like with every competitive exam. Possibly, I know it's be it CSIR NET, GATE or JAM exam. This result is really useful. And it says, if we have a differential equation dy by dx is equals to yx raised to power, some alpha, where this alpha lies from 0 to 1, strictly from 0 to 1. And let's say I have a condition, ya is equals to some x naught, whatever. I should write y naught. Ya is equals to y naught. And ya is equals to 0. Specifically, this y naught needs to be 0. So this result says that this initial value problem has infinitely many solutions. Let me give you a little idea about this, how this is coming. Infinitely many solutions. So when you have a differential equation of this type, let me give you an example. Y dash is equals to y raised to power 2 by 3. And this is another thing, right? This is a particular example of above result. I'll show you that it has infinitely many solutions, just to give you a little idea of how this thing is working, so that it sets into your mind and how to use it in exam. So if you have a differential equation like this with this given condition, y of whatever is equals to 0. It has to be equal to 0. Then only you have infinitely many solutions. So this is a sufficient condition. Again, this is not a necessary condition. So you need to keep that in mind. It need not be necessary for a initial value problem like this to have these conditions to have infinitely many solutions. There can be other conditions to have infinite solutions. But if this condition holds, then guaranteed this will have infinitely many solutions. So let me just solve it for you. Dy by y raised to power 2 by 3 is equals to dx. So when you apply variable separable method, what you will get is y raised to power 1 by 3 divided by 1 by 3. And what you will get is 1 by 3 x plus c y raised to power 1 by 3 is equals to this. Am I clear to all of you? Please, if you are having any doubts, you can tell me now. Otherwise, you won't be able to cope up. Okay, is it clear? Now we apply the condition. This is our solution and this is the condition. So when you apply this condition, y1 is equals to 0, what you get is you put y is equals to 0 and x is equals to 1. So you are going to get, in this case, is x is equals to 0. So you are going to get c is equals to 0, right? That's what you're going to get. This is a very important kind of question, and you must understand this, because without this question, you know, your whole study of ordinary differential equations
X equal to 1.
X is equals to 1, okay. Yeah. X is equals to 1. So c is equals to -1, right? So your solution comes out to be 1 by 3 x minus 1, or I can write it as this, right? Now your question might be, this is just a unique solution that we got. We didn't get any infinite solutions, but what I said from this result was that this must have infinite solutions. So let me tell you something, okay? I can write this y as let me x less than equals to c and x greater than equals to c. Okay. Let's see how this is, you know, like this. Okay. Now the given condition was y1 is equals to 0. And I am supposing that whatever c0 I have taken is greater than or equal to 1. Why I'm doing this, you know shortly. So if I say that this is a new solution for my differential equation, then it must satisfy the equation as well as the condition. So the equation is that the derivative should be y raised to power 2 by 3. When you do that for both of these cases, you will get to know that it satisfies the differential equation, no problem. What I have done is, the changes that I've made in this given solution is, this was the given solution, and this came out to be like a unique solution. But then I rewrite the solution like this: x less than equal to c0, this is 0, and x greater than equal to c0, this is this, which looks something like this: x minus 1 minus c0 whole raised to power 3 divided by 27. And I have assumed that c0 is greater than equal to 1. So it satisfies the differential equation. Differential equation is satisfied. Now the condition. What is the condition? That y1 is equals to 0. Now as c0 is greater than equal to 1, so y1 lies in this range. Remember, c0 is greater than equal to 1. So c0 can be equal to, let's say, 5. Okay. So for x less than equal to 5, you are assuming that the solution is 0. Yes, the condition is satisfied. And after that, you're saying the solution is this. This whole solution satisfies the differential equation on one hand, and it also satisfies the condition on the other. What is the condition? That y1 is equals to 0. So you are going to check that condition only on this part of the solution. So I have defined above solution as a piecewise solution now. And you cannot say that this is not a solution to my equation. This is also a solution to my equation. And this represents infinitely many solutions, because I can change C0. You know, for you, C0 could be 1.2. For me, C0 could be 1. For somebody else, C0 could be, 70. It could be anything greater than equal to 1. So When you're changing C0, you're getting infinite solutions. How many infinite solutions? If you've read like real analysis, you know that these are uncountably many solutions. So this initial value problem has infinite solutions. This is a very important concept. If you don't know it already, you must be very careful while doing this. You got this solution like this, and I knew that, I could just partition it. I could define it piecewise with the help of this C0. I mean, how do you even get an idea to define a function like this? Because most of the equations have unique solution. And you might say, how do you get an idea of, doing all this kind of weird work? Let me tell you. Coming back to our original question, which is very important. Let's see. Again, I'm asking you this one question. Does y is equal to 0 satisfies this equation or not? Yes, please, can somebody answer? Is y is equal to 0 is a solution for this differential equation?
Yes, ma'am.
Y is equal to 0 is a solution, but when I solve it with my traditional method, which was variable separable, and you can solve it with any method, you will get this same solution every time. When I solved it, there was no y is equal to 0. There was just these cubic curves. So y is equal to 0 is a solution, and you have missed that solution while solving. So all these missed solutions, I told you before, they are called the singular solution. Okay, so in such cases, I have told you even a theorem for this question. If such kind of a question comes where you know that this system has infinite solution, or it might be missing, you can also guess it by putting y is equals to 0. It might be missing some solution like y is equals to 0. That missing solution will be singular solution, and this singular solution can also be called, the envelope of the general solution. So you get an idea that you're missing onto one solution. So when you're missing onto such solutions and you're getting another solution, you're getting two solutions, right? Before doing this weird kind of things with C0, you were getting two solutions, one y is equals to 0 and another this cubic kind of solution. But the question is, you can't get two solutions for a differential equation. Like in linear equations or in differential equations, you can only get infinitely many solutions or a unique solution. So we have we had a doubt. We had two solutions, so it means that it must have infinite solutions. Okay, so I defined it this way, so that y is equals to 0 is also a solution to this equation. And when C0 is equals to 0, when you put C0 is equals to 0 or C0 equals to 1, you get y is equals to 0 as a solution, and you get all these solutions which also came here. So this is a very important way of defining a function to get those missing infinite solutions. Okay, so this is the actual solution of your system. Now coming back to the question that came in the exam, and this is one question that came in every single exam, even TIFR, GATE, CSIR-NET, wherever you want to find it, even in any MSc entrance, you can find this question. It's a very important type of question. So it says that alpha is from 0 to 1, the number of differentiable functions from 0, 1 to 0 to infinity, having continuous derivative on 0, 1. So these functions are very differentiable kind of functions. They have a continuous derivative. If this solution, this is your system, y dash t is equals to y raised to power alpha, where alpha was from strictly 0 to 1, with this condition that y of whatever is equals to 0, then now you know that this kind of system must have infinite solutions, and you can even find them if you wish to. How will you find them? When you solve them, you can solve them in the similar manner. This is an exercise for you to do at your home. Y dash is equals to y raised to power alpha, where alpha is 0 to 1. You can solve it by variable separable, and when you solve it, after solving it, you get such a kind of solution. Where did it go? Yeah, this kind of solution. But you know what you have to do? You just need to take any C0 which is greater than equal to 1, or whatever that point was given inside y. y of 0 is equals to 0. So in that case, you can take, C0 greater than 0 or whatever greater than equal to 0, right? So in that case, you will define the solution in the similar manner. One is 0 or less than equal to C0, and another one is x minus 1 minus C0. If you're having any doubt regarding this topic, you can ask now, because this might be something new for you. It can be a little hard to digest at the beginning. So you can ask just now. We'll move on to some easier topics after this. I'm giving you 1 minute, please. If anybody has any doubt, you guys can ask. I'll also share this, whatever I've written here. I'll make a PDF and share with you. Otherwise, we'll move on to our next topic. Okay, is everything clear to everyone?
Yes, ma'am.
Okay, that's really nice. You're clear. Okay. Now, what is an exact differential equation? This is a very important topic for some MSc entrances and for JAM also. So this is a very, unignorable kind of topic. So you can't ignore it. What is an exact differential equation? We say that any differential equation of this form, m dx plus n dy, where m and n both are functions of x and y, this equation is called exact if, we have like a total differential for these functions. What does it mean? See, let me give you an example. If I take a function f is equals to, let me take a curve. Let me take a curve xy is equals to constant. If I take the total differential on both sides, what happens is d of xy, d of x into y is equals to d of c. D means differential. Differential of a constant is 0. And for this, it becomes x as it is, differential of y, into y as it is, plus y as it is, d of x. Okay? X dy plus y dx is equals to 0. Now, this looks something like this, of this form. If I compare, I'm going to get m of xy is equals to x, and n of xy is equals to y, right? Now, this differential equation, if you see this as a differential equation, you see that this is an exact differential equation because it was derived from a curve, f is equals to constant curve. So any differential equation which can be directly derived by taking the total differential of some curve is called differential equation. So I told you this topic in a reverse manner. I took a curve xy equal to constant. I took differential on both sides, and then I got this differential equation in which there was no arbitrary constant. So this means that this is differential equation. So when I got this differential equation, and when I'm going to solve for this differential equation, there is a method to solve the exact differential equation. You can just directly integrate and solve it. So what is the method for solving the such kind of differential equation? Is if the differential equation is exact. So how do you check even if the differential equation is exact or not? I'll tell you. But the solution for such kind of differential equations is m dx plus n dy is equal to, constant, where either y is taken as constant and either terms not containing x, right? I hope I'm right in this. I might have forgotten the way, but we'll figure that out while solving the questions. I don't have a very good memory, but we can figure that out. while solving the questions. So if you had a curve f equal to constant, and you can directly get an equation df is equals to 0, or you can say when you have a differential equation like this, when you this will be exact if you get f is equals to constant by directly integrating in this manner. So what is the condition for exactness? The condition for exactness is if some differential equation like this has been given to you, how will you check if this is exact? There's one condition, that del m by del y is equal to del n by del x. If this condition is satisfied, the partial derivative of this thing with respect to y is equal to the partial derivative of this thing with respect to x, then the equation will be exact. So I showed you this differential equation, y dx plus x dy is equals to 0. We just did this example. Let me check if this is exact or not. So what will I do is I partially derivate it with respect to y. I get 1, and when I derivate it with respect to x, this is n, this is m. So with respect to x, I get the same thing. So this means that differential equation is exact. Why not will it be? Because I derived it from this curve xy equal to constant by taking direct differential. So a differential equation which was derived from a curve by taking directly total differential is called the exact differential equation. You can see this definition written here. But not every first order differential equation is exact, and sometimes we have to make it exact. So we'll see that in those questions that we are going to do. Okay. Let me just share with you the question. Okay, where did it go? Let me pick some question. Yeah, I've got this. But let us discuss this question. Okay. This question is maybe 2020 or 2019 question. Whatever question I'm going to discuss here, I'm going to be of JAM, and they have been, asked in the past 5 years or so. Not very old questions we are going to discuss. We are going to discuss some fresh questions. And this is a curve that has been given to you. This is the general solution where C belongs to R. And this is the given differential equation. So they have told you that this differential equation is exact. And what is the value? They are asking what is the value of m at 1, 1. So what could be your first step while watching this question? What can we do? We have a solution for this differential equation. And we also know that this differential equation is exact. One thing, when you know that this differential equation, you can do, if you know this is exact, what you can do is the equating del m by del y equal to del n by del x. Right? So when you do that, what you get is del m by del y is equal to del n by del x. With respect to x, partially derivate, you get 2y. Right? So now, how will you find m? That's a big question. You can integrate it with respect to y, both sides. What you are going to get is, integrating both sides with respect to y. What you get is m is equals to y square plus some function of x. Why have I written this? Because when I again derivate it with respect to y, I'm going to get 2y plus some function of x. Partially with respect to y, derivative is going to be 0, so 2y plus 0. So you can write m as this, but this is not going to help you much. You will have to get back to the original curve where this differential equation came from. So what we can do is make a differential equation out of this curve. X square plus xy square is equals to c. Let's make a differential equation out of this curve. And we know that this is a solution and this is an exact solution. What will happen? When I differentiate it, what happens is 2x plus x as it is. Y square is 2y dy by dx plus y square is equals to 0. Am I correct? Yeah. Okay, so what you get is 2x plus y square, and I collect it, and plus 2xy dy by dx is equals to 0. That's what you get. Now, I want to make this in the form of m dx plus n dy. So to compare with the given differential equation. So let me just do it. 2x plus y square into dx plus 2xy into dy is equals to 0. So this is n and this is n. So what happens? Can you compare this with the original given equation? Yes, we can. m dx plus 2xy dy. Yes, it looks the same like this. m dx plus 2xy dy, right? So n is given, n is verified here, and m, you can compare it with m, you get m is equals to 2x plus y square. But they haven't asked you this function, they have asked you the value of m at 1, 1. So the value of m at 1, 1 will be 2 plus 1, which is going to be 3. So 3 is the exact answer for this question. And you can also compare your m with this. You got m is equals to y square plus 2x, right? M was equals to y square plus 2x. So the function phi of x, which was just a function of x I was talking about here, is 2 into x. Okay, y square plus 2x. So this is our phi of x. So actually what I'm trying to tell you, I made this question so long just to explain you that rather than following this approach directly, you could have gone to like this general solution, and you could make a differential equation out of this general solution by differentiating it, making a differential equation, removing the arbitrary constant, and converting it into this form. So this has been given to you so that you can make the differential equation. You can solve, you can differentiate the general solution, make a differential equation out of it, and convert it into this form which was given. And there you can compare with m like I did. So the main work which was important was this. So you can, while solving the questions, you can try many different approaches and you can get the best out of it. It's no issue when you start this question like this. No, not at all a problem. We have verified our question that it is correct and by solving it in 2 ways. But you need to know what is the best way that saves my time while solving the question. So you need to be careful about that. So this was the correct approach that we followed, and ultimately we got m is equals to 3. Am I clear to all of you? If yes, please reply by unmuting.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, thank you so much for this great response. You should know what you're doing. That's very important. And you have so much time to experiment before the exam. In exam, you can't do much experiments. You can do experiments, but there's no time to do a lot of experiments in exam. So experimenting is when you're preparing. In exam, you need to just, go for it. You need to know what you're doing. Okay, let me just tell you one more thing about differential equations. Because not always the given equation will be exact. So what we will do, I'll discuss with you this method to make it exact, which is a very popular kind of method and the easiest method. It contains of 2 cases. You have been given a differential equation, suppose in the question, and it turned out that it looks, something like exact, you are thinking of solving this equation with exact differential equation. You might have other ways too, but you're thinking, I could solve this differential equation with exact method, but it turned out that the partial derivative of m with respect to y wasn't equal to partial derivative of n with respect to x. The condition of exactness didn't hold. So what you're going to do now is try to make it exact. And sometimes in the question, they will ask you, how will you make this differential equation exact? They ask you directly. You don't need to think much. They ask you directly, how will you make this differential equation exact? From which factor are you going to multiply this differential equation so that it becomes exact? So that factor that we multiply while making, to make this differential equation exact, is called the integrating factor. So there's a fun fact about differential, exact differential or non-exact differential equations, is that it might be harder to find that factor, but once you find that factor, like, you know, this differential equation was given to m dx plus n dy is equals to 0, and this is non-exact. You can, in some cases, find a factor, I mean, a factor in x and y, whatever, a small function, which you can multiply with this. Let's say, let me call it xy for some, you know, let's say it is xy for some differential equation. You multiply it on both sides, n dx, n dy, sorry, is equals to 0 into xy. Xy into 0, you can write, is equals to 0. So you can multiply it and make this differential equation exact. So that's a fun fact about them. Not always that differential is going to be exact, but you know, we have ways to make it exact by multiplying it with the integrating factor. But how do we know what is that integrating factor? That we are going to study in these two cases. So first case says, if you don't have an exact differential equation, but you have this, like, you will always find while checking, you will always find this factor while checking the differential equation is exact or not. You'll always find these two terms, right? And if it turned out to be something, when I divide it by n, it turned out to be something as a function of x. Or case 2 can be, when I was checking it and their difference came out to be, this difference divided by m came out to be a function of y. So this means in the first case, I can say that multiplicative integrating factor is going to be e raised to power integration of f of x with respect to x. And in this case, I can say the integrating factor is going to be some function of y dy. You know, this f could be different than, I mean, than a previous f. So I'll just write like gy dy, right? So I'll show you with the help of an example, which came in previous year. So yeah, how will you remember it? There's a way that I do remember it. How will you know that which of these two methods are useful for you when you're solving this question? So how do I remember it? Whenever there is n, there is going to be n, right? And the function that is going to turn out is going to be a function of x. You know, while I'm solving this, the function that we are going to get, f of x, is going to be a function of x, this x. And here it is m, so you divide by m and check. And here it is y, so function is going to be a function of y. And integrating factor is going to be nothing but e raised to power the function dy, right? So let us go towards the question directly. That was all for the theory. Oh, I'm so sorry. Just let me reopen that. Close the window accidentally. So is the screen visible to you again?
No, ma'am.
No, it's not visible. Okay, let me just share it again. Okay. I hope it's visible now. Please confirm.
Yes, Unnati.
Yes, ma'am.
Ma'am.
Okay, thank you. So let me pick one question out of this. And we are also going to cover orthogonal trajectory so that you have a better idea of. Yeah, I've got this question. Okay, let us try to solve this question. So here, this is a differential equation. They are directly asking you find the integrating factor. So let me just write what is m. Y plus, sorry, m is equals to, wait a minute, what's happening? Okay. So m is equals to y plus 1 by 3 y cube plus 1 by 2 x square. And n is 1 by 4 x plus xy square. Right? Now when we find del m by del y, what it turns out to be is 1 plus y square, right? And del n by del x with respect to x, it turns out to be 1 by 4, 1 plus y square. And that's really interesting because you notice when you take the difference, this is going to be a function of y. Okay, the function of y. So if you want to make it as a function of y, let me just do one thing. Del m by del y del n by del x. Let me check it with and divided by n, right? So what happens is, let me just not divide it by n. I'm just checking it, okay? It's going to be 1 plus y square minus 1 by 4, 1 plus y square. Now, the numerator comes out to be a function of y. Then let me check the denominator. How can I? Okay. So my n was this. Now, if I divide by n, let's see what happens. 1 by 4 x plus xy square. Right. So this becomes 3 by 4 1 plus y square divided by 1 by 4 into x 1 plus y square. So this turned out to be 3 over x. So I divided by n. Why did I divide by n? This is a very important question. So if you have divided it by m, you won't have been able to remove one variable, which I was able to do it here. When I divided it by n, I got a function of x only, which I wanted. So I divided it by n, and ultimately what I'm going to do, this turned out to be a function of x, and that's how it was supposed to be, right? This was supposed to be a function of x. This n and this n are same, and this was supposed to be a function of this variable, right? So now what is the integrating factor? The integrating factor is going to be e, integration of 3 over x dx. So it is going to be x cubed. You need to be very careful while finding these integrating factors because the options given are very confusing. They are, B and C option are very confusing. They are 3 log x and this is x cubed. Someone might answer it with B. What you get is now 3 log x. But you need to remove this log and e. So you get e raised to power log x cube. When you do that, you get x cube. Some student might get confused and might write 3 log x when in a hurry. I know it's not that difficult to judge whether it's going to be x cube or 3 log x. But while being in hurry, you can make this mistake and you might end up getting the wrong answer while wasting your time solving all the question, getting the right answer, but just end up getting taking the wrong option. So that's one tip from my side. The options that has been set by the examiner, the IIT professors, or whoever is making your paper are so confusing so that you end up getting the wrong answer. So C is going to be the correct answer. So that's a tip from my side. Now, let me share with you another interesting question. But before that, let me tell you, this differential equation? This is a very basic kind of linear differential equation. dy by dx plus function of x into y is equals to some another function of x. And for this kind of differential equation, if you find the integrating factor, this is going to look something like this. And the solution is going to be, we know that y into integrating factor is equals to integration of q into integrating factor in dx plus some constant, right? So this is going to be the basic solution for this. And actually, this is a method that came from exact differential equations. Again, I'm not going to go into the details of the proof, but this is an exercise. This is a homework for you to prove this formula for solution. I mean, getting this, how did we get this solution using the exact differential equation integrating factor method? How did we get it? Actually, this is the same as the formula that I told you before for exact differential equation, but this just represents a different form. And we have a direct formula for solution. So this is actually same as before we were doing. And if you change the variables from x to y, y to x, you are going to, you know, this is going to look something like this. Let me write it for you. Plus py into x is equals to qy. So when you change the variables, you're going to get the solution, which looks something like this. X into integrating factor is equals to integration of qy, integrating factor dy plus c. So don't confuse yourself when the variables are changed. Examiner might ask you, with changed variables. And in this case, integrating factor turns out to be a raised to power integration of py dy. Okay, so be careful with that. So let us discuss some more questions. Let me discuss with you this one. Just a second. This is a very interesting question, and you will realize after doing this question that you don't need to always solve a question while sitting in exam. You don't need to be a good kid. You need to be a, what do I say? You need to be a very clever kid while solving in exam. Okay. We have so much time to solve these questions after the exam. What is the correct way of solving these questions? But in exam, you need to be very smart. So this question is one of those examples. So this question says that dy by dx plus 10y is equals to f of x, x greater than 0. This looks something, like linear differential equation, which I just told you. And we don't know what f is. So that's a big problem. We don't know what f is. But they told you that this is a continuous function, and plus this limit of this function f is equals to 1. Can you tell me one good function that satisfies this condition, that it is continuous and the limit is equal to 1? Can someone tell me one good example of such f of x? Whatever first question function comes to your mind, you can share with me. After all, it's all about thinking. So just tell me. I accidentally wrote.
Constant function 1.
Yes. F x is equals to 1. I just wrote this function. So yeah, if you used your head, that's great. So f x equal to 1 is a one function that is continuous, and whatever limit you are going to take, on infinity or whatever, any point you are going to get, the limit is equals to 1. So why not I take this f x is equals to 1? They are saying that this is a question, this is a, and the good thing about numerical answer type questions is if your function that you have taken satisfies these conditions, you can take any, function that, does satisfy these conditions. Let me tell you what I'm talking about. So f of x is equals to 1. It satisfies the above condition. So I can take this function and solve this differential equation and check what the answer is going to come is equals to 1. Now, anyone from you can solve this equation. It's a very easy. You get integrating factor is equals to e raised to power 10, integration of 10, which is going to be e raised to power 10x something, right? And the solution is going to be, let me tell you, there's one more interesting fact. The solution is going to be y into integrating factor is equals to integration of q into integrating factor What is q? Q was f of x. F of x is 1 in this case. So 1 into integrating factor, which is equals to e raised to power 10x dx plus c, right? Now they have asked you the limit of y. They haven't asked you the whole solution, but where does the limit of this y goes? If I'm doing something wrong, some mistakes in calculation, you can just tell me. These calculations are very dangerous for me still. So e raised to power 10x, integrating, you get this, and like this, right? Yeah, we're good. I think we're good. Now I want to just, divide everything by e raised to power 10x. So I'm going to get e raised to power minus 10x. Is that fine, everyone? I hope it is. Yeah. Okay. There might be some calculation mistake, but that's fine, because what I want to tell you is how will you find the limit? You can just directly find the limit of y, which is equals to 1 by 10 plus something, some constant into this thing. As x approaches to infinity, e raised to power minus 10x approaches to 0. So this is going to be 0, and the ultimate limit is going to be 1 by 10. And that's how you find the answer. That's a 4-step question, and that's a very easy question. All those NATs that I've discussed with you are so easy that you can't even imagine, right? So this was a numerical answer type question. Even if you take f to be some other function, some other good function, which is very complicated, you could have taken like a function which could look something like this. I don't know. On infinity, it goes to like 1. You could have taken some complicated function which could satisfy these conditions, but there's no point of doing that because we want to make these questions easier for us. Okay, so the tip in this question that I want to share with you is, the tip is to take the easiest examples that satisfies the conditions. If I had the freedom to choose some example, in this case, I would have chosen fx is equals to 0, but that doesn't satisfy the given condition. So you just need to see the conditions and choose the easiest function that satisfies these conditions. And in this case, it was the constant function 1. And we solved it. You could take one complicated function and solve it for like this. In the same manner, you would get the same answer. So that's the trick that they use in exam. That's another trick. And now you know it. So don't be a good kid in exam, right? This is also one, kind of reasoning kind of question. We have like 20 minutes, so we can just discuss this question. And I'll also discuss with you one alternate trajectory question. Hope we have time. So what do we do in this question? They have given you some homogeneous differential equation. This question seems out to be a bit logical question rather than any method that we apply. Any student can attempt this question in exam. So what is happening here? Let me just, if fxy is a solution of the homogeneous differential equation, where equation seems something like this, 2x plus 5y into dx. Our first step while going to a question, while solving a question, is to identify the patterns that are being discussed in the question. So let me just observe what is happening in this question. Once I observe, I'll be able to handle this question easily. And this is minus x minus 3y dy is equals to 0. And here it is 2x plus 5y, which looks something similar to this. This is minus x minus 3y, which looks something similar to this. So if I put what can I do? I mean, I can just this is like a shifting kind of thing that's happening in the question. What I can do is I can put 2x plus 5y minus 1 is equals to some x. If I do that, let me just see what happens. 2x plus 5y minus 1 is equals to x. And 2 minus x minus 3y is equals to some, no, let me put that equal to n, let me put that equal to n. What happens? So 2x plus 5y becomes m minus 1, right? And 2 minus x minus 3y. So here minus x minus 3y becomes n minus 2. So if your original equation was m dx plus n dy is equals to 0, now the equation becomes the one that you have to solve becomes m minus 1 dx plus n minus 2 dy. Its solution was f of x comma y is equals to 0. What should be its solution? They have given you the solution f of x plus alpha comma y minus 3. F of x plus alpha comma y minus 3. Now what we can do?
Ma'am, it's m plus 1, right?
Which one?
2x plus 5y equal to m minus 1 or m plus 1?
M plus 1. Okay, yeah, you're correct. M plus 1. Now how can we compare the two solutions? Anyone? Alpha is equals to its solution is f of xy is equals to 0, right? And its solution is going to be x plus 1 and y minus 3. Something is something it could change here. Just yeah. So yeah, we can do it with another method also. See, we can compare the solution part. The first equation have this solution, f of xy is equals to 0. The second has this f of x plus alpha y minus 3 is equals to 0. Right? So if I put x is equals to x plus alpha, right? And capital Y is equals to y minus 3. What happens is I get small x as x minus alpha and small y as capital Y plus 3. You know, capital X minus alpha and capital Y plus 3. Right? Okay. Now we need to just see what this equation becomes. We can compare it. F of xy is equals to 0 and f of xy is equals to 0. Okay, this is the solution. X minus alpha, if I do this, x minus alpha plus 5y plus 3 minus 1. So this becomes 2x plus 5y. Yeah. So what I'm doing is I am substituting here small x is equals to capital X minus alpha. In the second equation, what I'm doing is 2x plus 5y, 2x plus 5y minus 1 dx plus 2 minus x, 2 minus small x. What is small x? X minus alpha minus 3 into y. Y is capital Y plus 3. dy is equals to 0. So this becomes 2x plus 5y. And the rest of the thing becomes minus 2 alpha plus 15 minus 1. Watch carefully. This is going to be interesting. Plus 2 minus x minus 3y. So I'm just going to write minus x minus 3y is going to be 2 plus 2 alpha minus 9. So 2 plus 2 alpha minus 9 dy is equals to 0, right? So this is it. I hope my calculations are good. 2 plus 2 alpha minus 9. Okay, right. So this
2
becomes
plus alpha.
2x plus 5y, yes.
2 plus alpha.
2 plus alpha, right. 2 plus alpha. 2x plus 5y minus 2 alpha plus 14 dx plus minus x minus 3y plus alpha minus 7 is equals to dy is equals to 0. Now, what I have done is, this given equation was in the form of small x and small y. Now, what I have done is, I have made this equation in the term of capital X and capital Y. Let me show you how. I made this as capital X and made this as capital Y. So I just completely want to compare these two. When I made this capital X and made this capital Y, I can compare the solutions. The solutions will be equal. And when I convert this into capital X, small x into capital X, small y into capital Y, I can compare the equations also. So the solution becomes the same. So the solution will also have to be the same. So finally, equation should be, the solutions are same. So these equations should be compared to 2x plus 5y dx plus minus x minus 3y dy is equals to 0. So when comparing, what I get is, variables could be anything, right? Small x or small y, doesn't matter. Their solutions are same. So these means the equation should be compared at the same level. So what happens is, when I compare the two, I get minus 2 alpha plus 14 is equals to 0. And in the same manner here, when I compare the two, I get alpha minus 7 is equals to 0. So from both of these equations, what I get is alpha is equals to 7. So what I did is, I found the value of alpha, which was asked in the question. So in summary, what I can say is, I want to make the solution of above equation look like the solution of the below equation. And then I can compare the two differential equations. And when I do that, I get this value of this, constant alpha, which was asked in the question. So I'm just making a little arrangements in the, second differential equation. So the first equation was in the form of small x and small y. Second equation is in the form of capital X and capital Y. So this doesn't use any use of differential equation. Any layman could also solve this question. You just need to know, the basics of differential equation. We didn't use any method or something like that. So exam is not about, knowing all the methods. It's all about knowing, using the right logics at the right point of time. So you need to remember this. So through this question, I wanted to tell you that it's not always the method that you know or the theorem that you know, it's also the logic that you use. Are you clear with this question, or anybody wants to ask anything with this question? You can ask any doubt if you have. So that yes.
How can you compare the equation, ma'am? The solution same means how can you compare the equation?
I have made them comparable by there's a method called homogeneous differential equations. When you shift, I have shifted, this was the solution of the original equation, right?
Yes, ma'am.
And I made the solution of the next differential equation to be like this.
Yes, ma'am.
I know that two different equations can have two same solutions. I understand your point. But here the thing was, the solution, the equations that were given in the same manner, these equations were same, except the fact that there was some addition of constant or something like that. So these equations belong to the same family, except some shifting was done by the examiner. So just do that in terms of single variable. X plus alpha need to be changed to some capital X or capital Y, so that we could identify what shifting was done. This is the same differential equation. That's what I'm trying to tell you.
Okay.
Different equations can have one solution, same solution. That's good point. But this is the same equation, some shifting has been done. For example, in XY plane, you take some point, x0, y0, and you shift it using some transformation, you shift it to some another point, x0 dash, y0 dash. The point was same, but there was some criteria that was used to shift them. And that was the same criteria that was used to shift the differential equation. And I was identifying what criteria was used. And once I identified, I made this differential equation look like the above equation. And that's how I find it. Yeah?
Okay, ma'am.
Yeah, okay. I'm glad you asked. Let me see if this question, let me give you a little idea about these questions, because you might all have some questions towards the Q&A session, so I won't be taking much of your time. This question is a very basic question, and you just need to use this form. You might realize that this is a first order, first degree differential equation. dy by dx plus px into qy is equals to px into y is equals to qx, and you can also use the exact differential equation method to solve this equation. But while solving with exact differential equation, you will get that this is a non-exact differential equation. Then you will have to find the integrating factor, but then you have like tons of methods. How will you identify which method to use while finding the integrating factor? So here comes the linear differential equation with first order, first degree, which saves our life. Saves us a lot of time, because here we have just a single formula for the integrating factor, E integration of px dx, and that's why it's useful. So you might all be wondering why, if it's the same as exact differential equation, why we shifted to this equation? Because we have a direct formula, we have this particular form, and we have this direct formula that we can apply to find the integrating factor. That's why we shift to this. Otherwise, we could have just stick to exact differential equations, and when the equation came out to be non-exact, we could apply these 5 to 6 methods of finding the integrating factors, and that could just waste a lot of time for us. So this is a very basic question. I hope you guys can do it. So I'm not gonna discuss it here, but if you have any doubt while solving any of these questions, you can ask in the group. You're always welcome, because these were the questions I planned that I'll be and this question is one which I want to, this is not an OD question, but I just added it for fun. So this is not this is a very basic calculus question that a 12th student can also attempt. So this came in, I think like, Jan 21. So I want you guys to take a screenshot. Also, I'm going to share this PDF. So please just take this screenshot, and your task is to solve this question. Put a timer in your watch and try to solve this question in 2 or 2.5 minutes, and send in the group, please. That's going to be very healthy kind of discussion in the group. So you can just take the screenshot and share its solution in the group. It's a very easy question. It uses a basic criteria. So please do. I hope you guys know what a gradient is. So I hope you've taken the screenshot. Please confirm.
Yes, ma'am.
Okay, thank you so much. And I am hoping that you will be getting its solution soon. Anybody is saying something? Okay, thank you, Anamika. Let me just move on to the last topic. It will just hardly take 10 minutes. And then we can discuss your doubts, any problems that you're having in your life or studies or whatever. I'll be more than happy to answer those questions. And this last question is also one, but let me just try to discuss both of these questions. I hope we can do this in 10 minutes. I know I take a lot of time in teaching, even small concepts, but that's how I am. So coming back to orthogonal trajectories, right? Trajectories, which is a very basic kind of idea, which says some curves could be, you might have a differential equation given to you, and that could be a one order differential equation. And for the solution for this differential equation could be, these curves, f of xy is equals to constant. Now, what these questions of orthogonal trajectories suppose demand you to do is to find the family of curves which are orthogonal to these family of curves. So what we are going to do in this is, when we have an orthogonal family of curves, the main idea is that the slope of one family and the slope of another family, their product is going to be equal to -1. So if this is equals to the, if this is the slope of first family, let's say the slope of family of, this family slope, and there's another family slope, and when we multiply these slopes, we get -1, right? So basically, if we can find the slope of another family, which is equals to -1 divided by this, thing, dy by dx, what I can get is -dx by dy, which is, the slope of another family. So what was the objective of finding the slope of another family? We are supposed to find another family, not the slope of another family. But the way questions are asked, they will give you a family of curves. Read out this question. Consider a family of curves, the equation of the orthogonal trajectory passing through, blah, blah, blah. So how will you find the family of curves, the equation of the orthogonal trajectory? The equation of the curves that are perpendicular to these curves. That their tangents are perpendicular, actually. At some point, you have like two families. The basic idea that I can give you is, there's a curve y is equals to 1 and there's a curve x is equals to 1. These two are orthogonal family of curves because they cut at, these are itself their tangents and they cut at the 90-degree angle. So what you're supposed to do is, you'll be somehow given a differential equation and you are fine to ask, for this differential equation, there is a solution. I don't know, some f of xy is equals to constant. But you won't be asked to answer the solution of this differential equation. You will be asked to answer the orthogonal trajectory for this, curve, whatever curve you're going to get. So what you do is directly, the method is just so simple. What you do directly is to replace dy by dx by -dx by dy. And whatever the differential equation is, when you solve for it, you get a gxy is equals to some constant. And the resulting family, gxy, is going to be perpendicular to this family, orthogonal to this family. So what I'm saying is, you will understand by this example. So let's do it. This is the easiest, one of the easiest topics of differential equations. So we have this differential equation. They are asking, find the orthogonal trajectory for this differential equation. So we use the method of differential equation to find the orthogonal trajectory. Let me do it. X square minus y square is equals to ky, right? So when I find the differential equation of this family of curves, dy by dx is equals to k dy by dx. Now k is a, what is k? Is an arbitrary constant. While making a differential equation, do you remember that you need to remove this constant? I haven't yet removed this constant. Once I remove this constant, I'll be getting a differential equation. But now this is not a differential equation. So I need to remove k. How will I do that? I'll use equation 1 to do that. And what I'm going to get is x square minus y square divided by y. That is the value of k. So yeah. And I'll solve for like dy by dx. Let me just do it. Is equals to dy by dx will be common here, right? So this will be 2y plus x square minus y square divided by y. And basically what you need to do is, let me solve it a little bit for you. This will be 2y square. So this will be, after taking LCM, x square plus y square by y. I hope that is going to be like this. So now what you need to do is you need to find the orthogonal trajectories. So to find the orthogonal trajectories, one thing is that we know for this differential equation, I mean for that curve, whichever curve was given, the orthogonal trajectory is going to be something whose slope is whose product of slope with this slope is going to be -1. That is, the slope of orthogonal trajectory is going to be minus dx by dy. So you replace simply, to find the OT, orthogonal trajectory, you simply replace dy by dx by minus dx by dy, and you solve the differential equation with your whatever traditional methods that you are going to follow. That is all you are need to do. So when you do that, you will get 2xy dy plus x square plus y square dx is equals to 0. I hope that is exact differential equation. So you can just solve it with the method of exact differential equation. And finally, what you get is the answer to this question. So I have left you to solve this question as an exercise. I hope you can do it. If someone has any doubt, I can solve it for you. But I hope you will be able to solve it. Okay. So the answer that you're going to get is going to be the orthogonal trajectory of the given question. So let me read out that question for you again. Consider a family of curves with parameter k belongs to R. Now, parameter means the arbitrary constant. So there was a family of curves. The equation of the orthogonal trajectory to this family, and that passes through 1, 1. Right? Once you find that curve, when you solve this differential equation, you get a curve which contains an arbitrary constant. Now, to remove that constant, what you do is you put that point 1, 1, and you will end up getting a beautiful curve like this. These options, one of these options will be your answer. I think it will be B or B or C maybe. So you can find your answer easily. That's a very easy question, and that came in JAM 2021. Now OD in JAM is really good. You can score well in the exam. I hope you have a good idea of these questions. Let me just share with you the idea behind this question also, and then we'll move on to the Q&A session. So what this question says is, this is a different kind of question, so I wanted to just explain it to you. Y is a solution of dy by dx plus y is equals to f of x, and y0 is equals to 0. But f of x is defined to be a piecewise function. So this question seems quite different from our traditional questions. So how to solve this? So there are two cases. You'll have to discuss these two cases: 0 less than x less than 1, x and x greater than equal to 1. So for this case, your differential equation becomes dy by dx plus y is equals to f of x, which is 2 in this case, and dy by dx plus y is equals to f of x, which in this case is 0. So when you solve this first equation, you get the solution like 2 plus, I'm just trying to write the solution correctly. Wait a minute. But you can use that method, which is d plus 1 into y is equals to 2, or you can just find its integrating factor. What's its integrating factor? Which is equals to e raised to power x. So solution becomes y into e raised to power x is equals to integration of 2 into e raised to power x dx plus some constant. So y is equals to 2 e raised to power x plus c divided by e raised to power x. So the solution becomes 2 plus c into e raised to power minus x, finally. And in this case, your solution becomes y is equals to c dash e raised to power minus x, because these two c's need not be equal, they can be different. So solution in this case becomes this. Now, they have asked you, so the solution, the final solution is going to be a piecewise kind of solution, because the f of x defined was piecewise. And you can see I have solved this differential equation in two different cases for these, when x lies from 0 to 1 and x greater than equal to 1. Now, given that y0 is equals to 0, so what will happen is y0 is equals to 0. When x is 0, y is also 0. But where is x 0? X is 0 in this case, the case 1. In the case 1, our x is equals to 0. So I need to put this condition in here, not on the case 2, because that case 2 is discussed. This solution is for x is greater than equal to 1. But this case is for x greater than equal to 0 and less than 1. So y0 is equals to 0 is a condition which will be applied in case 1. That's what I was trying to tell you. And when you solve it, you will get, I think, c is equals to -2. So this will be 1 minus e raised to power minus x, right? Yeah. Okay. So in this case, you get a solution y is equals to 2 into 1 minus e raised to power x. Can we match the options? We haven't solved the whole question, but we can match the options. And all the options, that's a funny part, all the options in this case are same. So you can't cut any option. You'll have to solve the complete question. Now to solve the complete question, what will I do? You have got the solution for this case, but for this case, you have no condition. They have given you the condition just for x is equals to 0. Now what happens? How do I find the c dash? Because this c dash need not be equal to that original c. So what will I do is, my solution breaks at x is equals to 1. Whatever my solution is going to be, let me just write it for you. Whatever that solution is going to be, it just piecewise breaks at this point. And for in this case, this solution is this. And whatever it is here, I know that the solution of a differential equation is going to be continuous, because I can find at least first order derivative for this differential equation. Any differential equation has a continuous solution, and it's also differentiable at least up to first order. So I know that this solution is continuous at x is equals to 1. So what I do is I apply limit x approaching to 1 for this 2 into 1 minus e raised to power minus x is equals to the solution, whatever the solution was, c dash e raised to power minus x. I apply limit x approaching to 1 both sides, and what I get is 2 into 1 minus e inverse is equals to c dash e inverse. So when you solve it for like c dash, what you get is, let me just write it for you, 1 minus e inverse, you will get 2e minus 1. So 2e minus 1 into e raised to power minus x, that's what you get as your solution. Okay, so this is your final solution, and this says that this option is correct. So A option becomes correct. Okay, so that was the question. That was all the questions that I wanted to discuss with you today. So I had discussed a variety of questions. Now, if you have any questions regarding anything, you can discuss. Over to you, sir.
Thank you, Unnati, for this very vibrant session on ordinary differential equations. I'm very much thankful to you for inspiring our students, and your session will be really helpful them in their preparations, and I am sure that they can score a good mark from that ODE part. Students, now it is your time to interact with Unnati.
Ma'am, today's session was so nice. I am able to understand each and every topic you discussed. Thank you for taking our session. Thank you, Vinod, sir.
Good afternoon, ma'am. Good afternoon, sir. I am Anandi from 𝐏𝐚𝐫𝐭 College. Today's session was very nice, ma'am. I used to understand everything in that part. And thank you, ma'am. Thank you, sir.
I had a question. For OD, can you refer some books, ma'am?
Yes, basic book, the most basic book that I can refer is S.L. Ross's book. That will give you a clear idea of what, how things are going on. And you can for practice, you can follow M.D. Rai Singhania. But at the end of the day, it's you who decides the kind of approach that you are going to apply on these questions. But yes, you need to refer to books. So first for theory and conceptual building, it's going to be SL Ross. And when you are ready to practice, you can follow MD Singh as well.
Okay, ma'am. Thank you.
Following those tips and tricks that I told you today. Yes.
Okay. Thank you, ma'am.
Sessions further on, whoever is going to take these sessions is going to be helpful for you. So try to attend these Sunday sessions. These are very helpful.
Thank you, ma'am. It's a valuable session for me.
Session. Thank you, Vinod sir. Ma'am, can you repeat the name of the textbook for practicing problems?
I can write the name of these textbooks in the group. Okay, are you in the group, Maths Aspirants?
Yes, ma'am.
Okay, I'll write the name of these textbooks in the group for your reference. Yeah.
Thank you, ma'am. Thank you, Vinod sir.
Ma'am, I'm Anushra KM from Malabar Christian College, Calicut. Ma'am, today's session was very informative and I could get a better understanding of ODE. Thank you, ma'am. And thank you, sir, for organizing such a wonderful session. Thank you.
Thank you, Answara.
Thank you, Ansu.
Hi, ma'am.
Yes.
Hi, Amal.
I am Amal. I am from Iritty, Mahatma Gandhi College, Kannur. Ma'am, the class was so interesting, and the topics we were already known for somewhat, but the questions you discussed were very interesting, and the tricks and tips that you had given were very much helpful for us. Thank you so much, ma'am.
Thank you, Amal. Thank you so much. Means a lot.
Good afternoon, ma'am.
Yes.
Yeah.
Unimaya, and I'm from St. Jesus College, Ernakulam. The class was so interesting, and you were sharing many tips and tricks for approaching each and every question. That was pretty useful for us. I have a doubt. In between your college exams, semester exams, how do you manage to prepare for this exam?
Well, actually, you need to know where your time is going, first of all. And you need to be the king of your time. That's what I believe. And but yeah, it's difficult to manage while your college exams, and it's difficult for me too. It's no doubt in this. But try to save your time from things which are wasting your time. It's mostly that we waste our time doing stuff, in our phones these days. But you need to know where your time is going. If you don't know, you can just keep a note of it and keep a diary, or maybe use Google Calendar to manage tasks. So at the end of the day, everyone has like 24 hours, but people are managing. People on the other hand are managing it so good, and some are wasting their time. So there are no tips that I can give you. You are the master of your own time. So just try to know where your time is going and try to make the most out of it. That's what I can recommend.
Thank you, ma'am. And thank you, sir, for organizing such a wonderful session.
So thank you, ma'am, for spending your valuable time for us. Thank you, sir, for organizing such a wonderful session.
I'm third year BSc Maths student of Zamorins Harapan College. Ma'am, thank you so much for this wonderful session. It is really helpful for us. We really enjoyed it. Thank you so much for your time and effort. I would also like to know about your preparation journey and also your life at IIT.
Yeah. So my preparation journey has been different from a lot of students because I prefer teaching while preparing. So yeah, that was it. When I started teaching, my concepts made more clear. And when my students used to ask me questions, I used to have this, I need to answer this the next day. When I wasn't able to answer that question in the class. So my students are one of the reasons that I was able to, be in this IIT. And the life at IIT is also, really good, and I'm enjoying it. And maybe that can be the motivation for you to go into IITs, prepare really hard, because the competition out there is really tough. So you need to prepare really hard, and you are going to thank yourself after you get into an IIT, because there are lots of opportunities for you after you get into such a premier institute. It's not just about a tag, it's about the opportunities that you get. That's what I believe. So yeah, that's it. That's my experience has been amazing for past few months. Yes, Malvika.
Thank you, ma'am. And also I would like to thank Vinod sir for conducting such a wonderful session for us. Thank you, ma'am and sir.
Thank you, Malavika. Sri Lakshmi, you started to say something, please.
Ma'am, I'm Sri Lakshmi from Ernakulam St. Teresa's College. Thank you for a wonderful session. And the tips and tips you provide was very helpful for us. Thank you, sir. And thank you, ma'am.
Thank you, Sri Lakshmi.
Yes.
Just like the previous one, it was very understanding. Thank you so much. You always prefer different variety of questions and it's very useful for us. Thank you so much. And I would like to ask you that you really have a great rank in our dream exams. And I trust that you should have, it's obvious that you should have worked hard. And we are preparing and we are trying our best. I trust, but still, is there any way to maximize the effect that we have to cover a lot of theory and also we have to practice more questions? Both are important. If you don't know the theory, we can't cope up with the questions. But if we don't practice questions, we will become slow in attempting questions, and that's also a problem. So, how can we maximize the efforts we are taking? Just like you said, instead of being a good kid, sometimes we have to be a clever kid. So, I would,
Yeah, always, you have a very limited time in exam. So you need to realize that for 180 minutes, you can't, solve every question and, do this kind of work. Because at the end of the day, you have MCQs and you get the right question, you get the right answer, that's it. So my tip would be to know how can you save your time in exam. And to do that, you need to find out the easiest way, because everyone is preparing for the exam. But at the end of the day, who will crack the exam? The one who solves the problem in less time. It's not about that you do everything. It's about that you do a limited amount of things and you can manage your time to, solve those problems in a very limited amount of time. Plus the theory and question thing that you asked is, you do the theory of a little topic and you try the questions regarding that theory. You can't do theory for like 1 month, or you can't do questions for like 1 month. That won't be of any use. So suppose you have done linear differential equations. Now you try to find the questions of linear differential equations, which you can easily find on, Telegram and everywhere. The questions have been arranged by many institutes. You don't even need to take coaching or something else for this. You can find free resources everywhere these days. There's YouTube, there's so many resources, there's so many websites, there's Telegram. So just do the theory of one topic and find the questions and see. If you're not getting the questions in one time, don't demotivate yourself. No one gets the questions in, first hit. It's about practice. Whatever you want to achieve in life, it's just about practice. The more you practice, the more you become good at it. So a lot of students, what they do is, while solving theory, they're very confident that they have cleared all their concepts, but while solving questions, when they come to questions, they're not able to solve it. And then they become, very demotivated. That's what you should not do. You should try again and again while starting your preparation. At the mid of your preparation, you will realize that you are able to solve many of these questions. And some students, I'll be very honest here. Some students are able to solve some questions very easily, very fast, and some students are not able to do this. So you need to realize what is your speed of learning things. You could be a slow learner, or you could be a fast learner. So realize that you are a slow learner or a fast learner, and according to that, prepare accordingly. You might have to study 1 hour more than some, brilliant student. That's fine. You don't need to be very demotivated, like he's doing it's, he's studying 2 hours a day and, he cracked this exam. Don't be like this. You are unique and you need to find your own way of, figuring things out. But at the end, I would say, find out the best way to do it. How can you minimize your time and maximize your efforts, not just in exam, but while preparing? So yeah, that's the tip from me.
Thank you so much, ma'am. Thank you, sir, for such a wonderful class.
Welcome, Harita. Welcome.
Thank you, Harita.
Hello, ma'am.
Yes.
Hello, Aarti.
I am Aritty from Tirur, TMT College, Tirur, Kerala.
And thank you so much for this nice session. And really
Really nice session.
Thank you so much, Aarti. Thank you so much.
Thank you so much.
Thank you, Iritty. Yes. Anamika.
Anamika from Dhanbad College. Thank you, ma'am, for this well-prepared session and well-collected questions. And repeating that is always a problem for me, and you repeatedly explained that. Thank you for that, and thank you also for the session.
Thank you, Anamika.
Thank you, Anamika. Thank you so much.
Any others? Yeah, no.
Hi, ma'am. I'm Anu from St. Teresa's College at Ernakulam. The class was very informative and I liked the problem solving session very much. We have discussed many problems and it is very beneficial for us. Thank you, ma'am, for taking such a wonderful class. Thank you.
Thank you, Anu. Thank you so much.
Yeah, thank you, Anu. Is there anyone else? Unnati, let me ask something.
Yes.
So, could you share something about your course, current course, M.Tech in Data Analytics, and what are the things that you are studying in that, and what are the career possibilities?
So, sir, basically, this is a course for data analyst or data scientist post. So, basically, data analyst or data science is a very emerging field these days. So, this is a very mainstream course, and we have subjects like machine learning, which is a very important course for data science. And we have some math subjects like numerical methods, and we use techniques to solve different kind of problems regarding data, how to manage data, and how to filter data and how to get information from some data. So data science is all about that. And in different subjects like numerical methods and machine learning, soft computing techniques, or be it any statistics. Statistics is a great part of data science. So you can't ignore statistics. So in all these subjects, we study how to manage data and how to extract the maximum information from data. Suppose, I can give you an example. Suppose we have a data for like cancer patients. It could be blood cancer. So what are these attributes that are, working on this, the heart rate of the patient, or, blood levels or whatever. So with the help of that data, we try to identify how serious is the cancer is. So that is the real life application of, what we actually do. So this is a great, interesting field, I would say. And for math students, it's also very good. If you don't want to go into teaching or, academics, you can prefer to be a data scientist. And other IITs are also providing this same kind of course, like IIT Guwahati, IIT Roorkee, IIT Madras, and there's maybe one more IIT, I don't remember the name. So these are the same kind of courses that are being provided by these IITs. So yeah, it's good for math students and all other students like from CS background, B.Tech in CS, they also come in this course. So many of my classmates are from CS background. So this course is both for CS and maths. So it's a mixture of CS and maths.
And
yeah.
As you have done your MSc in mathematics with computer science, I think the things will be more easier for you.
Yes, sir, a little easier, but yeah, I have to struggle a lot in this course because the level of computer science is really high. So before coming here, I can advise you, if someone is planning to, you can brush up your computer science skills, maybe Python or C++ or data structures. If you're planning to do so, we can have a whole session on this. But yes, for math students, brush up your computer skills, and for maybe computer science students, maybe a little bit of maths concepts need to be brushed up.
Okay, thank you, Unnati. The one point that I like in the character of Unnati is that she is really fond of teaching and very crazy about sharing the knowledge. So that's a very good one, especially for a platform like ours. People like Unnati is really a very boon for us, I think.
Thank you, sir. Thank you so much.
Once again, thanks to Unnati for joining with us, and I hope that you will be there in future also to help our students. and wish you all the success in your career and in your studies. All the best for your studies. Thank you, Unnati. Thank you, everyone. Let us
Thank
find
you,
out.
everyone. Thank you so much, sir. It means a lot. I'm able to interact with students with the help of your platform, so that means a lot for me, sir.
Okay, thank you, everyone. Let us find up here.